Well, this is the microcontroller based system. This is the encoder inputs, and this is the analog signal conditioning board. This is the FRM-KL25Z, and right now we are controlling the rotary inverted pendulum, as you can see in here. This is static space design using a Kalman filter, and we implemented it using the Kinetis Design Studio, and we made all the matrices calculations in C code, and we developed the controller using Matlab with the functions lqr and lqrd. And right now you can see the free master, and this is a pretty amazing tool because we can debug and we can watch the variables in real time. Right now what you're seeing is the angles of the inverted pendulum. The red line is the pendulum angle, and the blue one is the speeds, and the orange one is the arm speed. So as you can see, we can watch all the variables in real time, and we can change them if we want on the fly. And this is pretty amazing because the students in the control systems area are able to change the parameters of the controllers and watch them on real time. So right now I'm going to show you how I made this and how I made the design of the controller and the computer program. In addition, we are using the optimal control theory to make a following tracker using the touchpad in the KL25Z. If I move in here, if I move the touchpad, you can see in the pendulum that I am able to move it according to what I say. This is optimal, and we need to make all the calculation and the metric multiplication to do that. And additionally, we made a composed Kalman filter to estimate the variables. As you can see in here, these are let me show you here. These are the variables that are running into the microcontroller. The green one is the real variable, and the orange one is the estimated variable. So when we let me see here, when we activate the Kalman filter, it is supposed that the variables are going to be more smooth. So I already activated it, and you can see that the variables, although the movement is wider, the variables don't have so much noise. So this is the Kalman filter. We used arrays to develop it, and these values were developed using Matlab and using the solution to the algebraic Riccati equation. So we developed a custom made matrix multiplier function, as you can see in here. And additionally, we estimated the speeds using a derivative filter in order to be compared with the variables estimated by the Kalman filter. It was only for comparison. Okay, you can see this is the touch position, and this is what we did with optimal control, and this is what makes the controller to follow to track the movement that I do with my filter. Additionally, we use the processor expert, and this is pretty cool because we can develop the libraries to configure the libraries and that are going to handle the peripherals. You can see here int A1, int B1. These are the external interrupts that we use to develop the encoder, the optical encoder functions, and we used a state machine to decode these signals and to get the angle of the arm and the direction of the movement. And you can see that we use two PWM signals to manipulate the motor driver. So this is pretty cool because we already implemented these kind of tools in the digital control systems course, but we use classical digital control. So right now we are able to implement this kind of systems in the state space course. This is called linear systems analysis, and the students are going to learn how to develop their state space controllers and implement them in the Freedom KL25Z. And I say it again, one of the coolest parts of this work is the FreeMaster tool, and I really recommend it to be used. And it's pretty easy to use, and you can use it without running the Kinetis. The Kinetis Design Studio doesn't have the option to debug the variables in real time and actually graph them. So you may use FreeMaster evenly to develop a graphical user interface for industrial applications. So the students are going to use this kind of tools in the following semester, and we hope that they accept it. So thank you. I think this is all, and if you have any questions, you may make a comment to this video, and I will be glad to answer your questions. Thank you.